All right, hello again, pre-calculus people. So we're going to start talking about something called the rational root test, which is something that enables us to find the roots of a polynomial function, um, which sounds like it might be hard to do, right? Because like you can have a calculator and just doing it by hand. There's, in theory, an infinite number of places, but the rational root test actually tells us how to kind of narrow those choices down. I'm going to do this in a couple different steps. And the first step is what we're going to talk about today, literally just narrowing those choices down, not finding the roots yet, just seeing what the choices are or where those roots would have to be. Okay, so first of all, quick review on what a polynomial is. The definition is up here. I'm not going to read that to you. Basically, the exponents have to be positive integers, and also the coefficients have to be integers also. Okay. Um, So, in other words, you're not going to see any fractions of x, like 1 over x or 1 over x squared, something like that. You're also not going to see any fractional powers of x, which means you won't see any roots or something like that. So, no fractions, no roots. Okay. Now, we did this when we did the curve sketching stuff about a week or so ago. I remember the degree, though, the degree is just the biggest exponent that you see. Usually going to be the first term, the first exponent that you see in the polynomial, unless everything's kind of jumbled up together. But usually, if it's in standard form, going to be the first exponent. Same thing with the leading coefficient. It's usually that first term, that first coefficient, but it is attached to that largest exponent term. Okay. Okay. So what does the what is our goal here? Again, our goal in a couple of days is to be able to take a polynomial and completely find all of the roots. Now, once we get down to a quadratic, then we have tools to solve those. It might be factorable, quadratic form, or something like that. But until then, we've got to have some different tools at our disposal. Okay. So basically, what happens is we do this thing called the rational root test. The statement of that is in this paragraph. Again, I'm not going to read that to you, but essentially what it's saying is what I have kind of highlighted here. For any polynomial, if it ever crosses the x-axis at a rational number, it will be somewhere on the list of fractions that is made from factors of the constant over factors of the leading coefficient. Okay, what that says is the only thing that we care about is the leading coefficient term and the constant term. That's it. The middle terms are not going to make this list. Okay, so the first thing I like doing is looking at the constant. So in this case, it's 12. Listing out all of the factors of the constant. So in other words, anything that divides evenly into 12. So it'd be 1, 2, 3, 4, 6, and 12. And then do the same thing for the leading coefficient, which in this case would just be 1. So the only factor of 1 is obviously just 1. And then what we do, we're going to make a list in this kind of format. So every factor of the constant is going to be over every factor of the leading coefficient. Now, in this case, my LC is just 1, so there's only that one factor. So this is going to be a pretty short list. But in the examples we'll do in a couple minutes, we'll see the list can get longer if there's more factors, if the LC is something other than 1. Okay. Now, the one thing we do want to do when you make the list here is all of these things are going to get a plus or minus, because obviously 12 can be divided by 2, but it can also be divided by -2. Okay, so there's always going to be that plus minus here. So in this case, again, I'm going to take all of these just over 1, and that's going to be my whole list in this case. So plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. Okay. And keep in mind, again, these are all technically over 1. I just didn't write it over 1 because I didn't have to. Okay. And that's really what you got to know. Now, we're going to do a couple more examples with some longer lists and some different leading coefficients with different factors so you can really see what's going on. But that's it. And then in a couple of days, when we start really doing the full-blown problems, is we will have to test these factors to see which one is a zero. And we have tools that we've already done to do that. And then figure out what the rest of the roots are that way. Okay. So let's do a couple more examples. So let's take a look at them. So again, remember, the only thing we need is the constant and the leading coefficient. In this case, my constant is -4. The sign really doesn't matter because they're all going to be plus or minus anyway. So this is just kind of more for your information. So the factors are 4, 1, 2, and 4. The LC in this case is 3. So we got a couple extra ones here. So we got 1 and 3 for the factors of the leading coefficient. And again, the order that you make the list in does not matter at all. What I like doing though is taking each of the constant factors and then just putting one by one. So everything over 1 and then everything over 3. So I'm going to list them out that way. So plus or minus, again, over 1. So 1 over 1. And I'll write this just to make sure you see where it's coming from. So 1 over 1, 2 over 1, 4 over 1. And then, so that's all of those. And then everything else over 3. So plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. And then that's all of them. That's all of those. And again, remember, we do want to put the plus minus in front of each of those because it can be either positive or negative when you're dividing those into. And that's your whole list on that one. Okay, so I got one more example here. I've actually got two more, and we'll do both of those. So if you want to pause the video real quick and see if you can find our list of possible zeros from this function, and then I'll come back in and finish that one out, and then we'll do the last example. Okay, so again, constant is 5, leading coefficient is 2. I will say this, you will learn to really like it when both factors are prime, because they won't have as many choices. The last example we're going to do is going to have a lot of choices, and you'll see how much longer the list gets when the numbers are not prime. So my constant is 5, only factors are 1 and 5. LC is 2, and the only factors are 1 and 2. So again, when you make your list, it's always the constant over the LC. So plus or minus 1 over 1, plus or minus 5 over 1, and then plus or minus 1/2, and then plus or minus 5/2. And that's it. That's all there is to that one. And again, the middle terms don't matter at all. They'll matter later when we're testing the roots, when we have to do the division. But for making the list of possible roots, they don't matter. Okay, last one. And again, if you want to pause the video one more time, this is going to have a lot of choices. But I will say some of the choices will repeat. And so you don't have to write as many as you might think at first. So you go and pause the video, write out your possible factors, and then then we'll finish this one up. All right, so again, we have our constant of 30 and our leading coefficient of 8. So constant here, lots of choices here. So we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. So that's kind of a long list just right there. And my LC is 8, which means I've got 1 and 8 and 2 and 4. Yuck. So I've got to take each of these over each of these. And again, over 1, that's the easy one. We're just going to make that first list. So 1 over 1, And again, if you don't want to write it over 1 and just write the numbers, that's obviously fine. Up to you. Now I want to do the next set. So now I'm going to put each of these things over 2. But watch what happens on some of these. So 1 over 2, obviously I need that one. Plus minus 1 over 2. But then 2 over 2, I don't need it. Because 2 over 2 is just 1, and I already have it. Right? So I don't need to write that one down. 3 over 2, yep, need that one. 5 over 2, need that one. 6 over 2, that's 3. I already have 3, so I don't need that one. 10 over 2 is 5. Already have it. 15 over 2, okay, need that one. And then 30 over 2 is 15. I already have that one too. So that's all I need for the 2's. And that's usually going to happen, folks. Not all the time, but a lot of times if you have these real long lists with even numbers, stuff like that, a lot of times you're going to get some repeats that you don't have to write down. Now, look, I will say this. If you had written down 2 over 2 and 6 over 2 and stuff like that, if you wrote those down, I'm certainly not going to count it wrong because it's fine if they repeat. But if you want to save yourself some ink or some lead in your pencil, then you just kind of keep an eye out for those ones that can reduce. Now we go to the 4, so we got 1/4. Definitely need that one. 2 over 4, that's 1/2. I just wrote down 1/2, so I don't need them. 3 over 4. 5 over 4. 6 over 4 is 3 over 2. I have that one too. 10 over 4 is 5 over 2. I got that one too. 15 over 4, need that one. And then 30 over 4 is 15 over 2. Have that one too. So that one's done. And then we just go through the last ones, everything over 8. And some of these repeat too. So 1 plus or minus 1/8. 2/8 is 1/4. I got it. 3/8 I need. 5/8 I need. 6 over 8 is 3/4. I got it. 10 over 8 is 5 over 4. I got it. 15 over 8. And then 30 over 8 is 15 over 4. And I have that one too. So that is the whole list. Now that is a lot of numbers. I ain't gonna lie. There's a lot of things to check. And when we do the next step, we are going to see how we can use these lists to see what is a factor and hopefully get down to where we can find all of the roots of a polynomial. We'll do that next time. Until next time, stay safe.